Hey everybody, welcome to the rock dating study session. We're going to go over two main parts of rock dating here. The first one is relative rock dating. So we've talked about this in class and used the example of your relatives, saying that I'm the middle child of four. I have one older sister, a younger brother, and a younger sister. That tells you your age relative to your siblings, but it doesn't tell you how old you actually are. That's the exact same thing that we do with rocks, and we tell which one is older or younger, but we do not tell the exact age of the rocks. And here's how they do it. There's a couple different principles or laws that they use, geologists use, to figure out the relative age of rocks and fossils. So here we go. First one is the law of horizontality. And then the word I want you to look at is horizontal. You can see that word in there. That means flat. So the law of horizontality means that all the rock layers were laid flat at once. Now later on they can be tilted. Sometimes you'll see rock layers like this. But that might be because there's two plates coming together and it's forming a mountain or a volcano or something like that. But all layers were originally laid flat. So that's the first law. Alright, the second law is law of superposition. And this is where the oldest layers are on the bottom and the youngest layers on the top. I always think of everyone put your hands in, like before a football game or something like that. The coach has everyone put their hands in. The person that's hand is there first is always on the bottom, and that's been there the longest. That's the oldest. So you got oldest on the bottom, youngest on the top. Alright. The third law is the law of cross-cutting, and this says that anything that cuts through a layer of rock has to be younger than the rock around it. And the example that we've used is like a sandwich, and this actually kind of looks like a sandwich, this picture. If you picture this is the bread, and this is the ingredients, and you've got another piece of bread there. You make the sandwich first, and then if this is a knife cutting through, the sandwich had to be there first. So the rocks are always older than the thing that cuts through it. And then again, with superposition, this is older than the cross-cutting, but the oldest is always on the bottom. So now we'll talk about fossils and how we can also use fossils to help relative date rocks and tell which rocks are older than other based on the fossils that they're in. So all a fossil is a solidified form of an animal or a plant, an organism that was living, and fossils are called it's called an index fossil. An index fossil, just like if you look at the back of a book, the index of a book, it gives you an exact page number to where you can find that information. Well, it's the same thing with these fossils. So these fossils lived only for a short amount of time, and they were spread all around the world. So if you find a fossil, let's say if you find this fossil right here, okay, you know that it had to come from this time period. There was no other time period that it was around. The same thing if you found a rock layer with this fossil in it, you would know that this fossil is younger than that simply because it was only around during this time. And the first fossil was only around for that time in the Paleozoic. Okay, so then if we look at, and then a trace fossil is just, it gives evidence that an organism was there, like it's just a trace that they're around, like footprints, or this is an actual piece of fossil poop that showed there obviously had to be an animal there, but you don't actually have the animal, you just have the remains of the animal. So that's called a trace. And then one thing with all of this is extinction. The big rule is that if there's a species that dies out, it can never come back. So once you get down to the last species, the last individual, then the species goes extinct and it can't come back later in time. So the geologists use that to kind of order fossils in the rock layers. All right, so that was all relative dating. That doesn't give us any absolute age or exact how many years ago. This is where absolute dating comes in. So absolute dating is fairly new. It's like 65 years old. And the one you may have heard of before is called carbon dating. And how it works is that every element, just like things in the world like food that we eat, eventually breaks down and gets decayed. And so scientists have been able to figure out how long each element decays. And we can use that information, look at a fossil or a rock, and see how much is decayed and tell how old it is. So the big vocab word here is half-life. Half-life is a measurement of time, and it's how much time it takes for an element or carbon to decay by 50%. And so I'm going to give you a better example here on the next slide with a visual. But if there's half of the active carbon that is left and half of the decayed carbon, that would be one half-life. And scientists have proven that one half-life for carbon is 5,730 years. So if you were to find a fossil that had half of the carbon and half of the decayed carbon, you know it would be exactly 5,730 years old. And then if there was 1/4 left, meaning it got decayed by half again, then it would be double that, so it would be 11,460 years old. This will make more sense when So if you picture this as like, I like to think of food. So I think about like a banana. That's a terrible banana. It looks more like a chili pepper. Let's call it a chili pepper. All right. So our chili pepper, you buy it at the store, set it on the counter. Over time, that's going to get rotten and decayed. And so as it comes down, eventually there's going to be half of it is decayed. So now it'll look kind of nasty. And half of it will be alive still, I guess, or the original. That would be one half-life. And in class we discussed for a banana or a piece of fruit or whatever, that would be probably like 2 to 3 weeks, maybe a month would be its half-life. Well, elements break down a lot slower, so like we said, carbon was 5,730 years. There's some elements that take billions of years for a half-life, like uranium is 4.3 billion years. So that's a long time. So anyway, so we're at half decayed right here. If we continue to go down, eventually we decrease by half again. So half of 50 is 25%. So if 25% is remaining, that is 2 half-lives. And if we continue to decay, this banana or chili pepper is continuing to rot. You get down to the third half-life, which is 12.5. And then the next one would be 6.25. And then it gets smaller and smaller and smaller until eventually you have nothing left. And so this is, if you think about the banana example, that's where it's actually decaying. This is it's turning into a stable atom from a radioactive atom. So that's called radioactive dating. Radioactive dating. All right. And that's it. So again, this is called absolute dating because it gives you an absolute time, an absolute age. You can tell exactly how many years old it is. Relative dating just tells you which one's older or younger. And fossils can help with that too. If you have any questions, please let Mrs. Briarcliff or me, Mr. Olafson, know. And hopefully you ace the test. Thanks for watching.